Hi, I wanted to talk to you guys today about counting atoms in molecules and then balancing chemical equations. So, do you guys remember what the law of conservation of mass is? Think about that. And then also, looking at and counting each type of atom that's in these formulas. So we are going to talk about this. So the learning target that we're going to cover is counting number of atoms in a chemical formula and balancing equations by supplying coefficients. So the law of conservation of matter or mass is just that we can't create or destroy things, we just kind of change them. So in chemical and physical changes, for chemical changes, we're just breaking bonds and forming new ones, but overall the total mass is going to be the same. So here's like a picture, even if this reaction happens, you form new products, but the mass will be the same at the end. Balancing chemical equations, we use coefficients, and those are the numbers written in front. So these two red numbers are coefficients. And remember the subscripts are there because of the name or their balancing charge. It's a Brinkelhoff. Remember those diatomic molecules? So the subscripts are there because of the way the chemical formula is correctly written. So we don't want to change subscripts. We only change the coefficients in front. Before we balance, though, let's just talk about counting. When we balance something like this, sometimes we'll just keep this poly together and say that we have 2 ammoniums and 1 sulfite. But there will be times where I actually want you to tell me how many of each type of element. We did something like this when we did our what's in a color lab. So this is what we do. We actually think of that as a 1 and we distribute this 2 through. And then there would be a 1 and a 3. So in terms of nitrogens, I have 2 nitrogens, and then I have 2 times 4, so I have 8 hydrogens, 1 sulfur, and 3 oxygens. So I'm going to have you try this one. So this one's a little different. I have the 3 in front, which that's a coefficient, which means I literally have, 3 of these. It'll take me a little while to write them, but so you can literally write them out if you want to help you to count, but I'll show you what we do mathematically so you don't have to do this. But that 3 means I have 3 of these. So what I do now is similar to what I did above, where I'm going to distribute any coefficient. So this one is just a 1. The 2 doesn't go to that. It only goes to what's in parentheses, but then I multiply it through. So I have 3 calciums, and you can see that over here in my picture that I have 3. And then now I'm going to remember that there's an implied 1 here and here. So 2 times 1 for 2 hydrogens, but then I also want to multiply it by 3. So there's 6 hydrogens. Similarly, 2 times 1 for the phosphorus, so there's 2 again times 3, or 6 phosphorus. Oxygen, 2 times 4 is 8, times 3 is 24. So balancing chemical equations now, just some things to keep in mind, and we'll just apply these as we do some examples together. We don't want to touch the subscripts when we're balancing. We're trying to make the number of each type of atom equal on the reactant and the product side, but don't change subscripts. Balance the polys as 1 unit if you can. I'll show you that it makes it a lot easier. If you have an element that's found in more than 2 compounds, leave it until last. Usually you want to leave hydrogen and oxygen. It can be kind of difficult. Leave those until last, and sometimes they work themselves out. Make sure all your coefficients are in the lowest ratio. You can use fractions like 1/2 if you want. And then you can multiply the reaction by 2 to kind of get rid of that. In balancing combustion reactions, I like to tell people to go in this order. and I always say CHO. So we want to balance the carbon, the hydrogen, and then the oxygen. So let me show you what I'm talking about. So here's an example, and oops, I'm missing the yield sign, but when you're balancing this, you can like draw a line, and if you don't want to do this, that's fine. You just have to at least be thinking this way. So sometimes people will do this table where they list the elements that they're going to balance, and then this would be the reactant side and this would be the product side. So before I even start, I have 1 iron over here. I have 2 oxygens. And then when I get to the product side, you can see I have 2 irons and 3 oxygens. So I can balance these in any order, and I recommend that you use a pencil because sometimes you'll change your answers. But I'll just start with the iron. I want to have 2. I want to have it be equal, and I have to change just the number in front, the coefficient. Oxygen, 2 and 3 both go into 6. So if I put a 3 here, I have 6 oxygens. And if I put a 2 here, I have 6 oxygens. But now you can see that I just changed my iron to 4. So now I want to have 4 over here. So I will want to use my handy dandy eraser, erase this. And then I want to, change this now to a 4. Let me show you another. So here's an example where we have the polyatomic ion hydroxide. And again, we can kind of break this down. What I recommend is if you have hydroxide on one side and you have water on the other, for balancing, it's helpful to write the water this way. And then when I am balancing, let me show you a different way to do this. I'm going to balance these hydrogens. I'm going to balance the calciums. I'm going to balance the chlorides. And then I'm going to balance the OH kind of separately. So I'm not combining this hydrogen with the yellow hydrogen. So when I do this, I'm going to this time not use the chart, but kind of go back and forth. I'm going to count above. So I have 1 hydrogen, 1 chloride, 1 calcium, 2 hydroxides, 1 calcium, 2 chlorines, 1 hydrogen, and 1 hydroxide. And I want to make those equal. So I'm going to start with the chlorine. I have 2 over here. I want to have 2. Remember, we can't put a subscript. We're going to put a coefficient here. Now you can see I have 2 hydrogens, the yellow hydrogen. So I'm going to come over here. I want to have 2, so I'm going to put a 2 here. So while I'm doing this, I just changed these 2. And over here, I did change by putting that 2. I now have 2 and 2. So you can see now I have 2 and 2 of the hydroxides, 2 and 2 of the hydrogens, 1 calcium on each side, 2 chlorines on each side, and I'm balanced. So we can do the problems like that without setting up the table. If you did want the table, you would have, listed everything. But we would have kept that hydroxide separate from the hydrogen. Let me show you another. I have to scroll. Okay, so here's another one. I'm gonna again highlight just to help you to see the polys. So we have aluminum and we have phosphate. So this is one where we're using a polyatomic ion. And we also have acetate, another poly. And then we have, let's see, I'll pick a different color, like let's do green. We have sodium. So for this problem, see if it's, there we go. I'm going to do this one with the table. So I'm going to list everything I'm going to balance over here, and I'm going to keep my polys together. And then let me explain. So over here, I have one aluminum, one of these phosphates. It's all one thing. You can imagine that there's a parenthesis with a 1. I have one sodium, and I have one of these again, one acetate. When I come over here, I have one aluminum. I have 3 acetates because of this 3. So I'll go down here, 3 sodiums, and 1 phosphate. So I want to make these equal. So I'm going to want to, let's just start with the sodium. I need to have 3 sodiums so that they equal on both sides. So I'm going to put a 3 here. So now I have 3 sodiums and I also have 3 acetates. So I'm going to change this. And now I'm done. Pretty cool, huh? And then I think we'll just stop there. Actually, let me do one more with you. I'm going to do a combustion reaction. Let's do this one. So ignore this up here. So remember, one of the tips for balancing combustion is to go in the order CHO. So, you know, I can see over here I have 3 carbons, here I have 1. Hydrogen, I have 6 and 2. Oxygen, I have 2. And then over here this is where these can be a little tricky. I have 3. So I don't want to deal with that oxygen until last. So the first thing I'm going to do is balance the carbons. So I do want to have 3 carbons. Then I'm going to do hydrogen. And you can see that I have 2 but need 6. So I'm going to put a 3 here. Now everything is balanced except for, let's check the oxygen. So here I have 3 oxygens and here I have 6. So I have a total of 9. So this is an odd number, which I have an even number over here. I could go for 18 if I wanted. They both go into 18. It's also possible just to do a decimal, which would be 4.5 times 2 will give me 9. Or you could have also put 9/2. If you do this, then we would just want to take this whole reaction and multiply it by 2. So it would become 2 of these plus 9 oxygens makes 6 CO2 plus 6 waters. And you can see, you always want to check, these are not able to be simplified.